Hey guys, welcome back to the second video of calculating eigenvectors. In the previous one, we calculated eigenvectors for lambda equals 4. Since there was two of them, it was only necessary to do one. So in this part, we're going to calculate what happens when lambda equals 8, just to get a better idea of eigenvectors and understand different cases. So let's cut straight to the chase. So therefore, replacing lambda equals 8 here, and a minus 8i times the eigenvector u, which equals 0. And just solving this quickly, a minus 8i over here would give us, so this was pretty straightforward. So you pretty much subtract all these values by 8, because identity is a diagonal matrix of 1 times a is 8, subtract all by 8. So 4 take away 8 is minus 4, 6 take away 8 is minus 2, and once again 6 take away 8 is minus 2, and of course minus any value here, the rest of the matrix you just copy down since they all subtract 0, and here's the rest of the values. I just skipped it, so I don't want to waste anyone's time. Okay, so let's finish this off. So again, this part multiplied by the u vector, so u1, u2, and u3, and all of this, well, all this equals 0. Let's just put that over here. Okay, so let's solve these system equation. So what do we have here? We multiply this row by this column, we should get minus 4u1 minus 10 times this minus 10u2 plus 10 times u3, so plus 10u3. Good. And the rest of them, well, you know, this times this row, so I'll do fast. Minus 2u2 times minus 2u3. Again, minus 2u2 minus 2u3. Great. Okay, so now solving this, let's pick the last two because they're easy to deal with and equate them to 0. So straight away I can just cross out the 2, and if you were to solve this directly equal to 0, turns out you would get u2 equals negative u3. Okay, so good. So this is actually pretty helpful. Well, now we have this one. Let's try and calculate the first row. Okay, so let me just rub all of this out. I don't need the top off anymore. Okay, crap. Okay, so therefore using this one over here, we should get minus 4u1 minus 10u2 plus 10u3 equals 0. Replacing u2 with negative u3, we'll get minus 4u1. So this becomes a negative, this becomes a positive. 10u3 plus another 10, well, you get 20u3. Okay, plus 20u3. And solving this, plusing 4 across, this tells us that, let me think. 4u1 equals 20u3, u1 equals 5u3. Okay, so actually this isn't bad. So now what we should do here is associate a value for suppose one of them. You know, so far we have that u2 equals minus u3. So I would say in this case, you need to pick a random variable or random value for u3 or u1. But I'll pick u3 because all of them are in terms of u3. So I would say let u3 equal t. Therefore, we could say that u equals t with corresponding. So u1, if u3 equals t, that means u1 equals 5t. So put 5 here. If this one equals 3t, so it'd be u2 equals minus t. So minus 1. And once again, obviously this would have to be 1 as well, because u3 equals t, which is t times 1 is 1. It is t. Okay, and that's it, guys. This would be our eigenvector. Let me know if this was okay, and leave a comment below for any further suggestions. Thanks, guys.